Even in a space with no particles, no light, nothing visible, there are still tiny, spontaneous fluctuations. This is quantum vacuum noise. And from that invisible randomness, researchers have built an entirely new kind of machine learning system, one that uses light to compute probabilities. In quantum physics, vacuum is not still. Electromagnetic fields constantly fluctuate, even at their lowest energy state. This is a consequence of Heisenberg's uncertainty principle. You can't know energy and time precisely at the same time. These fluctuations, vacuum fluctuations, are a pure, irreducible source of randomness. They cannot be predicted or simulated. But that's exactly what probabilistic machine learning needs. Most machine learning models simulate randomness through algorithms or pseudo-random generators, a process that is slow, energy-intensive, and fundamentally artificial. Researchers from MIT and Stanford have taken a different path. They created a new computing unit, the photonic probabilistic neuron, or PPN. Here's how it works. A laser beam is pumped into a nonlinear optical cavity called an OPO, optical parametric oscillator. Due to quantum vacuum noise, the output light's phase randomly collapses into one of two values, 0 or pi radians. These represent binary 0 or 1. By adding a subtle bias field to the cavity, the system can control the probability of generating a 0 or a 1. In essence, it becomes a physical random number generator, tunable, fast, and rooted in quantum physics. When connected to a classical FPGA, these PPNs become the building blocks of a neural network. The researchers use them to classify handwritten digits from the NIST dataset. Each pixel is read by a PPN. Each layer in the network is made of multiple time-multiplexed PPNs. The output is not just a prediction but a full probability distribution over possible labels. Accuracy reached 96.5%, comparable to digital simulations. Then they went a step further. They used the same system to generate images from scratch, using a pixel CNN model. Starting from a blank image, each pixel was generated based on the previous ones, with quantum vacuum noise driving the randomness. From the same starting point, the system created different, unique handwritten digits, just like human imagination branching off from a single idea. But the true potential lies ahead. The authors propose a fully optical system, no electronics required. Sampling rates of 1 gigabit per second. Energy consumption as low as 5 femtojoules per operation. 100 times faster, 100 times more efficient than today's CMOS hardware. From invisible fluctuations in empty space, we now have the foundation of a new computing paradigm. Probabilistic learning powered by light and quantum physics. Not simulated randomness. Not synthetic probabilities. But real uncertainty. Harnessed at the speed of light.